So what I'm going to do first, ladies and gents, is let's look at the triangular prism one. All right. And let's work through that process. I've got these other ones that we were going to look at as well, but not yet. Okay. All right, guys. So please pipe up if you've got a question or you want to offer an answer. Let me know. I can't see you if you're waving your hand around because I've switched the cameras down. So just let me know. All right. So the big strategy for these type of questions that people tend to overlook is that if you have anything to do with an object, so in this case a triangular prism, and you're given its volume, all right, is you still use the volume formula, right, which we normally use to work out the volume. So people think, well, if I already know the volume, I don't need the volume formula, but that's what we're still going to use. So how do I work out the volume of a triangular prism? What do you have to do? What's the process? Well, that's a triangle. What about the triangular prism volume? Yeah. And then? Then what? Find the cross section and so the volume of any prism is the cross section area multiplied by what? The depth, yeah. Well, in this case, they've called it the height of the 3D object. So this is the cross section. This is the height, which is what we want to find, and this is the volume. So I cut those labels off. All right. So what I've done, you can see, is I've drawn a sketch of the prism. All right. Like I think I've said to you before, you should practice these things because it's nice that you can draw them well, and it helps your thinking as well. So the cross section we've got in a triangular prism is the triangle. Was that a question or a people are mowing the lawn? Oh well, we have to do our best. Turn your volume up. I am recording. All right. So we've got the triangle. Now the cross-sectional dimensions are the base and the height are 12 and 7. So, yeah, go for it. Good question. Is this height, are you saying this height or this height? Okay, so just to explain, so it's a very good question actually. If I draw it like this, the depth is this dimension here, yeah? Because I kind of stand it up and then I go backwards. So that's why I call it the depth. But to draw it slightly differently, okay, if I try and draw, this might be a bit trickier. If I draw this in this way, hopefully you can still see it. All right. If I stand it up like that, all right, then this would be the base and the depth would now be going straight up. So what would you call the depth if it's going straight up? Well, we would call it a height. Yeah. Right. So it's a difficult one. So it's a good question that you ask. Yes, the height is the same as the depth. It's about being flexible in your understanding because if I always say height or always say depth, you might then get confused if the prism is on its side, for instance. So in this case, the prism is laying flat on a table, you know, if I were to draw a table around it, okay? Whereas in this case, it could be sat on the table like that, all right? So you might even call it the length, but because we're dealing with lots of different dimensions that are all lengths, we've got to kind of label them something, all right? Does that answer your question about depth or height?
Yeah.
Okay. So obviously the slightly confusing thing there is that especially when you've got a triangular prism, there is another height, isn't there? So this height is actually the height of the cross section, the triangle. So we try and deal with that bit first. Where's the height of this triangle, the cross section, guys? So if I go call this point A, this B, and this C, how would you tell me where the height and the base are of that triangle? Describe it.
Directly down from B, like in a straight line, would be the height.
Yeah, good.
And the base is the line from A to C.
Well done. So this is the height, which is the 7 millimeters, and the base is from A to C, which is 12 millimeters in this case. And then obviously the depth is what I want to know. Okay. But I do know one other thing, and this is the thing people overlook. They forget to write this. I do know that the volume, the space taken up, is 286 cubic millimeters. What do you think, by the way? Is this a big object or a relatively small one? How would you interpret those numbers at the moment?
28 centimeters. So medium size.
Is it 28 centimeters, is it?
28 millimeters.
Well, it's 286 cubic millimeters. How many centimeters? So you can't really compare directly like that, millimeters cubed and centimeters. What we can do is compare 7 millimeters and 12 millimeters with centimeters. So do you know how many centimeters 7 millimeters is? Yeah, 0.7. And 12 millimeters is how many centimeters? So what do you think? Big object or small object now? It's quite small, isn't it? It's not even a whole centimeter tall. All right. So the volume looks quite a big number, but actually, if you think what a cubic millimeter looks like, well, a cubic millimeter would be a cube that is a 1 millimeter by 1 millimeter by 1 millimeter dimensions. All right. And actually a centimeter cubed, or a cubic centimeter, do you know how many cubic millimeters fit into a cubic centimeter? Any ideas? No? Well, how many millimeters fit in the 1 centimeter along that way? 1 centimeter is how many millimeters? What does the chat say? 100. It's not quite. Think about your rulers, guys. Your measurements. On your ruler, you've kind of got centimeter lines. Okay. Let's say it's 1 centimeter, 2 cent. How many lines are in between for the millimeters? It's not 5, actually. not. It's 10. Someone said it. So 1 centimetre is actually the same as 10 millimetres. You should check your ruler, right? You've got 10 little lines for millimetres, okay? So on a cubic...
One in like the middle of the 1 and 2 like centimeters, there's like a larger line in the very middle of it.
And that means that gives you halfway, and that's 5 millimetres. Yeah. All right. So there are actually 10 millimetres in between 1 centimetre. So that means a ruler, for instance, is 30 centimetres long normally. How many millimetres would it be? So for instance, if we have 1 centimetre, that would be 10 millimetres. If we get to 15, the length of a small ruler would be how many millimetres? There are chats happening. Sorry, I'm not seeing them. 10, 30. Okay. So 10 millimetres. This would be, anyone knows? Not 30 millimetres. It would be 150 millimetres. And 30 centimetres is actually 300 millimetres. Yeah, exactly. So back to my cube. Well, if one length is 10, the other length being 1 centimetre as well is another 10 millimetres. So my square is 10 by 10, and the height is another 10 millimetres. So what's the volume of a 1 cubic centimetre cube, but in millimetres? Well, you know, because it's a prism, it's 10 by 10 along the bottom to do the cross-sectional area. And then you multiply by 10 for the height. And what do you get? 10 by 10 by 10, you get 1,000. Okay. So 1 cubic centimetre. So that's one little square, a cube that is a centre, is tiny. It's probably smaller than well, it might be about the size of a die that you normally roll around. Well, one of those actually has 1,000 cubic millimetres in, because they're tiny little squares. All right. So this object here is only 286 cubic millimetres. So it's making it look even smaller now, right? It's a tiny little thing. So we're not expecting a big number here, right? Does that make sense to everyone? We've set up that situation. We haven't solved anything yet, but we're gaining a little bit more understanding. How do you feel about it? Any questions? Give me a positive yes if you're all good, or no if you have a question.
Yes.
Yeah, everyone good? Okay. Let's set out, let's use this information now. So we know we're not expecting a big number. All right. So that's my criterion D thing. That's about, does my answer make sense? Good idea if my answer is going to make sense. Right. So it's a big number. If it's a really big number, it might be all right if it's millimeters, but we'll see. All right. So what I'm going to do, I've got all this information. I know I'm going to rewrite this. So volume equals cross-section area multiplied by the depth or the height, however you want to call it. So let's write in the information. So what, in this case, what's the formula for the cross-section area? I think, David, you already told me that. Not quite. Finish it off. Base times height divided by 2. Good. And then we multiply that by the depth. Okay, or the height. I'm going to call it depth because I've got a height here. I don't want to confuse it with the same number. Okay. All right. Now what I do is I start putting the numbers in even if it's not in the place I expect it to be, I'm just going to put the numbers in. So the volume, does that have a number I could replace the V with? What is it? 286. Good. Do I have a number for the base? 12, yeah. Do I have a number for the height of the cross section? Yeah. Do I have a number for the depth? No. And is that what I want to work out? So what I'm going to do is I'm just going to call that. What do you want to call it? It's a number that I don't know yet. So what do we do in maths? I want to know.
Use X.
We could use X. I could use D, or I could use any letter I like. Do you want to use X? Are you happy with X? Okay. So let's put an X because that's the thing I want to work out. So I want to solve for X. All right. So let's put the information in here in the same way that we see it. So volume. So we've got 286 equals, the base is 12, multiplied by the height is 7, divide that by 2, and we're going to multiply that by X. So this is the thing that I need to work out, all right? So now I need to solve for X. What would you guys do? What would be your next step? So I've not done any maths yet. Well, I've done maths, but no calculating. I've just put numbers in that I know into the formula that I know because the formula's in your formula booklet, right? So that's not a hard thing. So what can I do first? What would you do to make life a bit easier at the moment? Yeah, go for it. What's the answer?
The answer is 42.
42? Because it would be 6 times 7. I was just going to write that. So 42. Yeah, so 42 times x. Are you okay if I write 42x now rather than times x? Because having a times and an x is a bit confusing. So I'm just going to do 42x for 42 times x because we did that, didn't we? So everyone okay with that? Okay, so just put in for our notes, don't use the times symbol. Right, what would you do here now then to work out what x is?
Times x equals 286.
It is. Do you want me to rewrite it the other way around, like that? Okay. So 42x is to. If it helps you, then that's not a problem. You can rewrite it. I do need to figure out what x is, though. How can I do it? What? Go on. Divide by. Sorry, I can't quite hear you. Divide by 42. Good. So I've got 42 x's. So if you remember on algebra tiles, that's like having, if one block was an x, we'd have 42 of them, yeah? And on this side of the line, we'd have 286. So we'd have to split the 286 into the 42 boxes to find out what each box was worth, yeah? So if we divide... So x is 286 divided by the 42. What do you get as the answer? 6.8? Can everyone do that just to confirm? Just to verify? Not saying you're wrong. I just haven't done it myself, so I just want to confirm. Yeah. Right. Is that what we were expecting then? So I always do this, guys. I would recommend you always do this, is write your answer on your diagram, okay? And check it makes sense, okay? And the best way to check it makes sense, remember, checking if something makes sense is not necessarily about checking your maths. Okay, your maths could be correct, but your answer might not make sense. So I'm going to go back up and I'm going to write in here that my answer for depth is 6.8 millimeters. And the way to check it makes sense is to do what, guys?
Multiply them all by each other and see if you get the volume you were given.
Well, that's not multiplying by each other. I don't multiply those three, do I? Because that's not how I do my formula. I'm going to, it's actually simpler than that, David. I don't need to multiply, but go on.
Times like divided by 2 and then take that number
And
and multiply it by...
Yeah, so that, again, you're checking if you're correct. That's fine. That's not a problem. Yeah, that's a good plan, is to put it into the formula and check your volume works, because you might have made a mistake. So we could definitely do 12 times 7 divided by 2 times 6.8. Do I get the answer 286? Should we do that check, guys? Can you just do it? Do we get this answer? Yeah, we're happy with that. But there is one other thing. So remember I said with criterion D, as is quite important since that's your assessment coming up, it's not always about whether the answer is correct, is whether it makes sense. So for instance, what I'm going to do to check if it makes sense, not if it's correct mathematically, but if it makes sense in real life, I'm just going to look at that number and I'm going to compare it to the other numbers that I've already got in the problem. All right. And I'm going to see, does that sort of make sense? So this is only 7, this is 12, this being 6.8, remembering that my diagram is what we say not to scale, because I didn't know what the size was, I just drew a random triangular prism. Does it make sense that 6.8 millimeters goes with a 12 millimeters and a 7 millimeters? Do you think? Yeah.
Mr. Potts, I got 285.6.
Yeah, that's what I got too.
Okay.
Same.
All right. So that leaves us to another. That's a good 285.6 exactly, or? Okay.
Exactly. No,
All right. So what have we got here? This is another awesome thing for a criterion D for you to talk about. Why don't I have the same answer? Is my worry lines on my face. Why is it not the same? Any ideas?
Rounded.
Okay, well, I'm going to stick. What did you get exactly when you did 286 divided by 42? You told me the answer was 6.8. Was it exactly 6.8? That's why I asked everyone to check.
6.8095238.1.
So 6.8095328.1 probably go on forever. 2381. Okay, well, I can stop there. All right. So you rounded here, didn't we? Running out of time, guys. I'm just going to have to restart in a minute. Not just yet. I'm going to restart and then we'll talk about your assessment. But this is a really important thing for your assessment, actually. So you have rounded your answer here. Was there any problem? Did you round correctly? So 6.8. Yeah, it's rounded correctly. I'm happy enough with my answer. But the check that you did, you put the rounded answer into the problem and expected to get exactly the same thing. You're not going to. It's going to be slightly off. All right, slightly different due to rounding. Now the question is this a problem? Why?
On criterion A tests, you'll get like lower score.
But it's not criterion A. So there is a criterion in criterion D, guys, if you have a look at some point. I haven't brought it up with me, but it does say you have to explain your degree of accuracy. Okay, now we have rounded this number to a level of accuracy that seemed appropriate. Okay, so we've rounded to 1 decimal place. Do we need a number all of these decimals long? Well, the answer is this is 6.8, and the important thing here is millimeters. It's only millimeters. Would any of you be able to measure 0.8 of a millimeter, let alone any of these values? Okay. No, I think the best we could actually do is go 7 millimeters. This is measurable. Okay, I don't even think you could measure 6.8, but it's fine. Like some people can, they've got special equipment, but we can't measure to these, definitely. So I think it's perfectly reasonable. So you might need to come back to this video. I'm saying a lot, but not able to write it all down. Okay, it's perfectly reasonable to have 1 decimal place when you, especially when you're dealing with millimeters. Maybe not if it was miles or something, you might want more. But that's the degree of accuracy that I've chosen, 1 decimal place. It's got nothing to do with am I correct? It's about I've chosen that degree of accuracy because that's reasonable. I am able to measure, let's say I can measure 6.8 millimeters. I can't measure 6.809 millimeters. It's just not possible without really specialist equipment. Okay, does that make sense? Okay, so when in criterion D, okay, so this is your criterion D. One of the big things in criterion D for you to consider is explain your degree of accuracy, and it's got nothing to do with are you correct. It's about how you chose how many decimal places you want your answer to, and 6.8 millimeters is reasonable to have. All right, especially, well, what's the degree of accuracy they've given in the question? You'll notice, look, that we've got 7 millimeters, 12 millimeters, and 286 cubic millimeters. So actually in the question, they've done it to what we would say the nearest whole millimeter. Okay, they've not used decimals at all. Now this might be 7.1 or 12.3, but we don't know. We're going to assume it. So we could, after working out 6.7, you could say, actually, I'm going to round to 7 millimeters because, and what would be the because? What have I just been talking about?
What was the question?
Have a lot of people switched off? Have you switched me off? Please don't, guys. Stay with me. If you're zoning out, this is really difficult to teach like this and learn like this. If you're switching the sound off or zoning and doing something else, then you might as well not be, especially if you've got assessment. All right, so I've just spent a lot of time talking about rounding numbers, and we've just said, like, they've given all their numbers are to the nearest whole millimeter. If I've got 6.8 millimeters, I could choose to round it to 7. Why would be that reason? What would be the reason I could give in an assessment?
Because it's not like a whole millimeter and it's not really like measurable.
Yeah, exactly that. Yeah, it's just not something I could measure. So I would write down my answer as 6.8, but I would then say I'm going to round to 7 because. All right, so don't just go straight to 7, put it afterwards and say my degree of accuracy is going to be the nearest whole millimeter because millimeters are so small. Okay. All right, so there's a lot there, guys. Just to recap what we've just done, we've had to draw a diagram. We've put in the information that I know. I've written the formula for the volume. The reason why I've chosen volume is because I was given volume in the question. All right, if it was not volume, if it was surface area, I'd use a surface area formula. But I've used the formula for volume. I've written it out. I've identified all the numbers that I've got. I've then rewritten that formula, but with the numbers. And then I've solved for X and we got an answer. Then, because we're talking criterion D stuff, we have to determine if that number makes sense. So we put it into the back into the diagram just to check that the numbers all make sense. You also did a check that the number gave you the right thing, and it didn't quite. It was slightly off, and we decided that was because of the rounding. But because we only have millimeters, having it to, let's say we even use 7, this number would be even more different, but it's not a problem. It's not incorrect as long as I can explain why I chose my degree of accuracy. So 1 decimal place or even the nearest whole number, it'd be up to you. So that's the process. Okay. Any questions or comment on that, or does it all make sense? All good. Right.
That makes sense.
Great. I'm just going to stop recording now. All right.